Hello, in this video I'm going to show you how you can code an encoder for using with MIDI. In the last video I used this project to make a one-knob universal controller where you can just hover your mouse over any parameter and you can move this encoder to move that knob, slider or whatever you want in any software, because it acts like a mouse, so you can go up and down or left or right. This way you can have a fine control over any parameter in any software. However, a lot of you ask me about how can I use this with MIDI, which is something I actually teach how to use inside my course, the Making Music with Arduino, among many other things. But today I'm going to show you how you can code an encoder to use with MIDI, okay? So first of all, why would you want to use an encoder? And what an encoder even is? You might know rotary potentiometers. Let's see this controller. This is the first controller I ever built with a custom PCB. I designed the PCB. I was using an Arduino Omega, so really prehistoric. And it has 4x4 or 16 regular potentiometers. A potentiometer, as you might know, it has a beginning and an end. So you know, judging by its physical position where you are, if you're in the middle, beginning, or end. While a rotary encoder is infinite, counterclockwise or clockwise, also called infinite potentiometer. So while you have a visual feedback of where you are, here you don't have with the encoder. With the encoder you will need an LED feedback or a display or some kind of feedback to know where you are. So why not always using regular potentiometers? This controller here has banks, so bank A, B, C, and I can store different values in different banks. So I can use this potentiometer to map one parameter in bank A and then another parameter in bank B and another parameter in bank C. So I can control different things depending on where, on which bank I am. However, if I am here, let's say, and then I change the bank and I move to here, okay, now I want to control that parameter in this bank. Okay, I changed here. And this was here, let's say 70, and the other one was in 40. When I move here, it will not start in 40, it will start in 70. So it will skip. We were in 40 and then it will skip to 70 and then we're gonna come back again. Okay, so the problem about using rotary potentiometers, regular potentiometers, is that if you are using banks, when you change the bank and when you move the knob, you will skip to that value corresponding to the actual physical position of the potentiometer. So potentiometers are not good for using banks. Ideally, you will map one potentiometer to one parameter and you will stick to it. Meanwhile, the rotary encoder, since it doesn't have an actual physical position, you can actually map this to different things in different banks, and what it does, it only decreases or increases the actual number of that parameter. You can just increase +1, +1, +1, or -1, -1, -1. So if you change the bank and you move the potentiometer, if you program it correctly, you can actually control different parameters without that skipping problem. So we have some famous controllers like the MIDI Fighter Twister. I guess you can change between banks, and then you also have the LED feedback here, so you see that the feedback will change, the position of the LED will change depending on the bank. So encoders, they are great, but they have this caveat of the feedback. And building, designing the LED ring, which I'm going to do soon, I'm working on a modular MIDI controller system, and these modules will have an LED ring encoder. So stay tuned for updates like that, so subscribe to this channel. So for this kind of thing, they are really great. But even though if you don't have an LED ring, you can see in your screen, it will work in the same way. So how the encoder works? So let's first take a look at one. So this one has 3 terminals, and we'll discuss how those terminals work. So this one it's used to increment clockwise or counterclockwise, but we also have encoders with more terminals and what those terminals do. So we have those 3, which is for controlling, for reading the encoder, but we have these 2 here that allow the encoder to have a click. So just like a regular push button. So those extra 2 pins, it's just another button. So you can wire this one to the ground and the other one to the digital pin and read just like any regular button. You can see those encoders also in a breakout board. So it has the pins here, also the encoder plus the switch. And you can also have illuminated encoders. So this one has built-in LEDs. It can be 1 LED, 2 LEDs, or even 3 LEDs, RGB LED. So you can have all the colors. So it will have more pins. So you need to be careful to read the datasheet and understand which pin is which. Okay? So now, how does this encoder work? We know that a potentiometer is a variable resistor, and I already made a class here teaching you exactly how to code potentiometers, so take a look there. But the potentiometer is a variable resistor, and a variable resistor is something that can change its resistance depending on where you are. So the more resistance, less current will flow through the potentiometer, and the less resistance, more current will flow. And then we can read this voltage, this change in the voltage, to know exactly the position of the potentiometer. This way we can transform this into MIDI from 0 to 127 and send control change with this value. But since we don't have a position, an absolute position with the encoder, it just goes clockwise or counterclockwise. How does it actually work? So let's take a look here in its terminals. It has 3 terminals. It has terminal A, terminal B, and ground. So the middle one you're going to connect to the ground, but the other 2, instead of connecting to analog pins like the potentiometer, you will connect to digital pins. So how do we know if it's turning clockwise or counterclockwise? So we can figure that out through a process called quadrature. So here is how the encoder is inside. It has 2 terminals, like I said, terminal A and terminal B. And we have a couple of conductive things, like some materials. And depending on the encoder, we will have more or less of those pulses, let's say. So here, let's say you're turning clockwise. This part will touch here, and this part here is connected to ground. So once it touches here, output A will be high, will be read high in the Arduino, while B will be low. Then, when both are on, touching this, both will be high. Then it's gonna go down. Output A will be low and B will be high, and then it will leave both low. So here we have a graph of how it works if we are turning clockwise. So this is output A in blue and this is output B in green. So we are turning the shaft clockwise. A is high and this is low. Suddenly this is high too, so there's a moment where both are high. Then the A will be low while green is still high, and then both will be low. So while you are turning clockwise, when the state of A changes, their state is different. See, every time A changes, they are different. Either one is 0 and the other is 1, or either one is 1 and the other is 0. But look what happens when we turn counterclockwise. When A changes, both are in the same state. Both are 0 here, both are 1 here. Always when A changes, both are in the same state. So in the code, that's how we can figure out if we are moving the encoder clockwise or counterclockwise. So there's the complicated way of writing this code, manually coding all of that. So before I go to the code, there's something really important. So remember that our Arduino code is read line after line in a loop. So imagine that you're turning the rotary encoder knob. Remember that you have 2 terminals. One is going to be on and the other one is going to be off, then off, on. Imagine that when you're reading the code, you do that, but your code was not fast enough to get that movement, to get that change in the state. And that happens a lot. What will happen is that you will miss pulses. You will turn the knob, it's not going to go fast as you want. So this method is called polling. When you just keep reading, and just hope for the best. This will give you a very slow reading. but it's doable if you don't need high precision. So the right way of doing it is using a certain kind of pin that has interrupts. So an interrupt is something that when the state of that pin changes, let's say from low to high or from high to low, all the code stops and goes to a certain function. It happens, doesn't matter where your code is, it's going to go to a certain function, to another part of your code to realize any kind of task you need. So that's what you need with your encoder. When any of those pins change its state, you need to go to a certain function. So with the library we're going to use, that's really fast. We don't need to worry about functions or anything like that. But we need to connect the A and B pins of the encoder to pins with interrupts in the Arduino. So which pins have interrupts? You will need to look at the pinout of each microcontroller. So for example, here, the Arduino Uno, you can see that this thing here means that the pin has an interrupt. So all of those here have interrupts. The Mega, you can see that those here have interrupts, those ints here also have. The Pro Micro, you can see that pins 2, 3, and then pins 8, 9, 10, 16, 14, and 15 have interrupts. So since you use 2 pins per encoder, and here we have 1, 2, 3, 4, 5, 6, 7, 8. I'm not counting these 2 here because those pins are used for serial communication. So since you have 8 pins with interrupts, you can use up to 4 encoders in the Arduino Pro Micro. So that's not a lot. So if you want more, for example, you can use a Teensy board that has more pins with interrupts. Bigger Teensies have way more pins, but also if you want to use more encoders with a regular Arduino, you can use a port expander as the MCP chips, which I teach how to use inside the Making Music with Arduino course. Each IC has 16 pins with interrupts, so you can use up to 8 encoders in each IC, and you can use, I guess, up to 8 ICs in an Arduino. So 64 encoders, that's a lot. So how we're gonna wire this encoder then? Here's how I am wiring this encoder. So A is going to 2 of my Arduino, the middle one is going to ground, and then pin B is going to pin 3. Since this encoder also has a switch, I'm connecting this to pin 10 and the other one to ground. But today we're not going to use the switch, since it's just like using a button, and you can see how to use buttons, and also I teach everything about buttons, potentiometers, encoders inside my courses, okay? But today, let's just pay attention on pin A and B. Today we're going to start from the example that comes with the Teensy library, and you can add this library, which is the encoder library, coming here to the libraries manager, and install this encoder by Paul Stoffregen. And you're going to open the encoder example, and I'm going to leave the examples that we are doing here for you to download. So you can see that you need to install the encoder library, and here in encoder is where you initialize the library, and here you give a name to your encoder. This can be anything. Let's keep my encoder, my enc, and then pin A and pin B. Since I am using pins 2 and 3, let's leave this here as 2 and 3. Just some serial begin here, just to have some text in our serial monitor. Here is a variable that we will store the previous position. So we need to compare if the previous position is different from the actual position to actually send number. So if the position now is different from the previous, print this number. So the only thing we need to do here is pretty simple. We have a variable called new position, which is reading the value of the encoder. So it's doing all the quadrature stuff in the background. You don't need to worry with it. So it will give you 10, 11, 12, or 11, 10, 9, depending on if you're turning clockwise or counterclockwise, and it will store in this new position. So if new position is different from old position, inside this if statement, and here we store the new position in the old position, so we can compare them later. Let's print, okay? So here I am using this port, and I am using an Arduino Pro Micro, which is the same microcontroller as the Leonardo, so I can choose Leonardo here. So let's upload the code. So you see that if I move counterclockwise, I am increasing the number, and if I move clockwise, I am decreasing the number. I'm reaching negative numbers, so it's inverted. So one thing you can do if the reading is inverted is just changing the order of the pins. So let's put 3 and 2. Let's upload. Okay, now if I move clockwise, I am increasing one by one, and if I move counterclockwise, I am decreasing. So this means that our circuit is working fine, and we can move to the next step, which is actually sending MIDI, okay? So the first thing I want to do is decrease that range, because I don't want negative numbers or numbers bigger than 127. Since the MIDI range is from 0 to 127, I want to decrease this range to those numbers. So let's do something here. So if new position is bigger than 127, then new position is equal 127. So if this number gets bigger than this, I'm going to store this number here. So it's always going to be 127 if it's bigger than 127. So I want to do that the same thing for if it's less than 0. If new position is less than 1, could be less than 0, new position equals 0. However, there's another thing we need to do here, that there's a function running in the background when we move the encoder. And that function is increasing and decreasing the number -1, -2. It doesn't care if I'm restraining my new position variable, because in the background, it's going on something else with another variable. So we also want to restrain the variable that's been used in the background. So for that, we need to use the library to do that. So myenc.write equals 127. So we are writing in that variable that's happening in the background this value here if our new position gets bigger than 127. So we need to do the same thing here, but now for 0. Okay, so let's take a look if it's doing what we want. Clockwise. It's reaching 127, and it keeps sending 127, and if we go down, reaches 0, it keeps sending 0. So another thing I want to do, just to be really elegant, I don't want to repeat numbers. We don't need to send 0, 0, 0, 0 or 127 repeatedly, okay? That's useless and it's just taking computer CPU, or it's just to be fancy. So what we want to do now is here where we are printing, we only want to print if new position is different than old position. And guys, if you are new here, I have this whole series of programming classes, which this one is part of, where I'm teaching since the beginning how to code. So take a look in this playlist, okay? The Arduino programming playlist here in the channel. You will like it. Okay, so only if the new position is different from the previous position, we are going to send a number. Okay, so let's see what happens. Nothing happens. So there's something wrong here. Oh, okay. So we need to update the old position at the end of everything. So this should solve. Let's see. Okay, so when I move clockwise, okay, it's going up. And when I go down, you see that now it stops in 0. It's not sending repeated values. And if we go up to 127, it stops in 127. So I always like to do this. Make sure that in the serial monitor, everything is happening as it should before I send MIDI message. So what I want to do now is turning this into a MIDI controller. So since we are using the Arduino Pro Micro, could be the Leonardo or the Micro, we can use the MIDI USB library, which turns the Arduino into a MIDI class compliant device. I also have a class about this here in this playlist. So first, I'm just going to paste a couple things here. I'm going to add the MIDI USB library, which you can also install here, the MIDI USB. Another thing I just going to copy and paste is this function here This is necessary for the library to work. Doesn't worry too much about what it does. And how we send a message, a control change message, we're gonna do control change, and I'm going to send right after this print because I know that here is where I'm sending the message. So control change, then is the channel, we can see here. So in the MIDI USB library, the first channel is actually channel 0. So if I want the first channel, the channel 1, I need to put 0 here. So 0, comma, then the CC number. So we have 128 CC numbers. Let's say I want CC number 1, and then the CC value, actually what is changing here, which is the new position. Let's see if everything is right. Okay, so now if we upload this code, we should have a MIDI controller. Okay, so I'm going to open here MIDI monitor so I can monitor the MIDI incoming message. Also, let's take a look here in the serial monitor. Okay, so when I move clockwise, you can see that we are getting message there. It's a little bit slow in the MIDI monitor, but let's take a look here in what matters, which is a DAW. So first let's go to options here. In MIDI, here in Ableton, we should see Arduino Leonardo. And we here have Arduino Leonardo and in and out. We just need in and we need remote to map something. So Command M and let's press here and move the knob. Okay, it's mapped. So now it's still choppy, so let's take a look on what's going on. Okay, so I know what's going on. It's something that I always forget, which is always after the MIDI message when using the MIDI USB library, you need to type MIDI USB.flush, exactly like here. Okay, so let's take a look now. Okay, now it's super smooth. So how would you use this with different banks? You just need to change the MIDI channel of this encoder. So let's change in the code. So here instead of channel 0, let's change to channel 1. Okay, so now if I move, nothing happens because it's not mapped yet. So let's map this second knob. And you can see that now it doesn't skip the value. You can actually see perfectly how it works because we don't have a button or something to change channels. And that's something that I teach how to do inside the Making Music with Arduino course. The Making Music with Arduino course is inside the Nerd Musician Pro bundle, and the Nerd Musician Pro bundle has the Making Music with Arduino, the Arduino programming, where I actually teach how to code. I go in depth in way more subjects than this, and also the KiCad PCB design, which is a course that I teach you how to design and manufacture highly professional printed circuit boards. And since this is my birthday week, I'm turning 37, thanks. And I always do a sale this part of the year. You can get a discount with up to 60% off in the Nerd Musician Pro or 40% off in the individual courses. And that just goes until April 9th. So hurry up if you want to get the discount. There I'll teach you how to build basically any MIDI controller you can come up with. You have the Making Music with Arduino, where you can just copy and adapt my templates to what you need, so you can build controllers really fast. You have the Arduino programming, where I actually teach you how to code, and the KiCad PCB design to design printed circuit boards. So I hope you enjoyed this video, so please let me know what kind of thing you want to learn next here in the comments. So don't miss the discount, it just goes until April 9th, and I'll see you in the next video. Ciao!